If you're familiar with different types of software tests, like unit and integration tests, but are left wondering how to get started using them to test your code, you're in the right place. Today, we'll talk about two common situations you might be in and software testing strategies that you can use to address them. This will help you catch bugs early, maintain clean code, and ensure smooth deployments. When most people are first exposed to software testing, they already have an existing project. This could be a project they've developed themselves or inherited from someone else. Either way, incorporating software testing strategies can improve the project. A common challenge in this situation is that the project's code wasn't designed with software testing in mind. For example, everything might be in one long, complicated script. That makes the first tests more difficult to write. In that situation, you want to get some tests in place with minimal code changes. That way, as you improve your project and make it easier to test, you know if you are changing behavior or breaking things in the process. This often means starting with a high-level test that checks the software's behavior, like a system regression test, to run our example script and check the final answer. This contrasts with a new project where we typically start with unit tests and smoke tests. Once you have those tests in place, then you can start refactoring your code while maintaining those initial tests so you don't break the larger project. As you do, it's important to think about what tests you will need and how you can write your code to make those tests easy to implement. A common starting point is taking complex scripts or algorithms and breaking them up into separate functions or methods that can be tested independently with unit tests. Where you go from there will depend on your project, but you should focus first on core areas of the software that many other pieces depend upon. Start by getting some tests in place quickly and with few code changes. Then, grow your testing setup as your needs and comfort with software testing grows. As you grow more skilled and comfortable with software testing strategies, you may become motivated to adopt more sophisticated techniques, especially for new projects. Test-driven development is a popular software development process in which we use our tests to guide us. We begin by listing all unmet use cases for our component. From there, it's an iterative process in which we begin by picking an item from that list and writing a functional test that satisfies it. We then run the test to verify that, since we haven't implemented that functionality yet, the test will fail. Next, write the minimum code needed to enable that functionality and make the test pass, without being overly concerned about things like performance, readability, or maintainability. Once the code passes the test, then, if needed, we can refactor our code to improve its implementation while ensuring the test continues to pass. Once we're satisfied, then we iterate and write the test for the next item on our list of use cases, and so on, until we have tests for all our use cases and code that passes those tests. As we continue testing, we run all tests each time for our component to ensure they all pass. This methodology has many benefits. It helps find bugs early because we have tests in place from the start. It ensures code remains aligned with requirements because those requirements are baked into our tests before we write code. It results in cleaner code because we only write the minimum code needed to pass our tests. Additionally, it helps verify the accuracy of the tests themselves, because you should observe the test fail first before it passes. The drawback of test-driven development is it can have a steep learning curve and requires discipline to consistently write tests before code. It is time-consuming in the short term, but greatly beneficial in the long term. Let's illustrate a quick example in MATLAB. In a traditional development process, we start by writing the code to solve our problem, such as our Fibonacci function here. Then, if we remember to do it, we'll write a test for that function afterwards. If the function contains a bug, it's only at this point that we'll discover it. With test-driven development, we write the test first, and then immediately run it with the expectation that it should fail. Then, as soon as the first version of our function is done, we can immediately test it and identify the problem. Writing the test first takes more time initially, but it gets us to high-quality code more quickly. Regardless of when or how you write your tests, they're no good to anyone if you don't run them. While having our tests written down does make them easier to run and repeat, ideally, no one should have to manually remember to run the tests. This is where continuous integration comes in. Continuous integration, or CI, is a service that automates running software tests and reporting the results. A CI service can be configured to run the tests based on a number of different conditions, but most commonly, the test will be run anytime a code change is submitted to source control. Running tests with a CI server has several benefits. It ensures that your component's latest version works with any new changes you or others working on the same project plan to incorporate. The CI server may also give us access to software or hardware we don't have locally, like say a powerful CPU cluster to accelerate our testing. And the CI server makes reports of test results visible to everyone on the project. All of this happens automatically, which provides rapid feedback, catches integration problems early, and ensures a reliable deployment process. The software testing strategies we discussed in this video are a great place to start, but there are many more strategies and details out there. If you're ready to learn more about other aspects of software testing, you can view all the videos in this series here. And to learn more about writing unit tests in MATLAB, see this video. Thanks for watching, and we'll see you in the next one.